Hey everybody, it's Mrs. Dinkelman, and we're talking about the last little bit in our converging or diverging of series. And this is where we talk about whether something is absolute or conditionally convergent. So if you noticed, and maybe I didn't say it specifically, but let's go perhaps back up and look at the ratio test and the root test. They do have absolute values in them, and I might have neglected to write them when I did the assignment or I did the examples, but it's because I knew they were positive anyhow. So because there's absolute values there, it seems like that test is just a little bit more, I don't know if strict is the word, but it just needs more to make sure that it converges. And so that's sort of where we can think about the absolute versus conditional convergence. So really, if something is absolutely convergent, basically if I take the absolute value of the series, I get a converging result, even with the absolute values around there. If it normally converges, but when I throw those absolute values around there, it doesn't, then that's called conditional. The condition being that you're not allowed to take the absolute value of it. So I just have a couple of examples here. So negative 4/5 to the n. So this is a geometric series that we know converges because, well, there's an absolute value in there again. The absolute value of the ratio is 4/5, which is less than 1, which means it converges. If I were to take the absolute value of this entire series, it would just turn into this one, positive 4/5, and I would get the same end result, which means it converges in this form. It also converges in the absolute form. So that's absolute convergence. Whereas this one, negative 1 to the n over n, this is a alternating series. In its alternating form, it does converge. But if when I take the absolute values, then it doesn't alternate anymore. And now it is the harmonic series, what diverges. So in this case, since both of them do not converge, I only get it converge in that conditional case where it has to alternate, then I'm going to say it's conditional convergence. If the series just diverges, we just, like in its an original state, then we just say diverges. Another, just a couple of absolutely convergent ones. So this P series, whether it's alternating or not, is convergent. So alternating series proves that this converges. Now it's a P series after I've taken the absolute values, still converges. The ratio test already has absolute value bars built in. So we could just use that test right off the bat, and I can see here that I'm missing some of my picture. We'll just go like that. So it is a really nice test to use because it already has the absolute values built in. So we get if we get a converging result here, we can say that it's absolutely convergent. Okay, so go through and determine on the assignment whether you get absolute or conditional convergence or diverging. I might throw one of those in there too.